Okay, so last time we discussed solutions of general linear homogeneous DE. The first two cases, case one, distinct real roots of auxiliary equation, and case number two, repeated real roots of auxiliary equation. Now we're going to continue our discussion by determining the solution of higher order DEs, specifically the general linear homogeneous DE with constant coefficient. And of course, for us to be able to determine its solution, so we need to find the roots of the auxiliary equation. So for case number three, it will be about distinct imaginary roots of that auxiliary equation. In case number four, repeated imaginary roots of the auxiliary equation. Okay, so let's skip cases one and two since we already finished it. If you have any clarifications about these two cases, you can actually, send me a message or chat here, or maybe later we can answer, or I can answer your questions. Okay, so case number three, it involves distinct imaginary roots of auxiliary equation. So suppose that the root of the auxiliary equation is imaginary. Okay, so it contains an imaginary unit I. Say for instance, a plus bi. So this is a complex number with a as the real part and b, or this term, is the imaginary part. And it has to be noted that the conjugate of an imaginary root, of course, which is a minus bi, is also, one of the roots for a complex number. So, and it's included. Now, for this particular root, having complex numbers as, root of that auxiliary equation, then your solution will be again distinct. Okay, so what makes it distinct is the sign. So a plus bi, and the conjugate is a minus bi. So this is how you write your solution. So as you can see, I have written here c sub 3 e raised to a plus bi times x. So I have utilized c sub 3 because this is not yet final. Okay, because we're going to derive, the solution for this one. And c sub 4 for the second term, e raised to a minus bi x. Okay, again, so it has two terms, two arbitrary constants since you have two roots. Okay, now rewriting this solution so we can actually combine and then factor or represent this exponential function into this format wherein e raised to the quantity a plus bi times x is equal to the factored form e raised to ax times e raised to bix. The same with the second term. You can actually rewrite this exponential function into this format, just following the law of exponents. Okay, so before we simplify this, let me present the Euler equation. Okay, so because we are going to use this in our derivation for the solution, okay, to simplify further this solution. Now, e raised to I theta, an exponential function containing an imaginary unit, is equal to cosine theta plus I sine of theta. So we call this Euler equation. Again, so any exponential function containing, of course, an imaginary unit I is equal to cosine theta plus I sine theta. Okay, so where theta, may it be in radian measure or in degree measure, but most of the time we represent theta in radian measure. Okay, the following illustrate the other equation. So let me present this illustration for these are valuable for the derivation later. Okay, so it should be noted that e raised to I times ax. Okay, so let theta be equal to ax. So we can actually rewrite this solution to cosine of ax. Again, so this is theta plus, you just copy the imaginary unit I and then sine of ax. Clear? Now for the next one, we have negative. Okay, so e raised to minus I times a. So it is negative. So we carry the sign here. So cosine of minus a plus I sine of minus a. Now, it should be noted that, okay, if you are to check this in your calculator, maybe if you know the idea for this one. So cosine of a negative number, say a, is equal to the cosine of the positive number. Okay, please take note. Cosine of negative number of that number a is equal to the cosine of the positive. For example, cosine of negative 90, if you check that in your calculator, it will give the same answer to the cosine of positive 90. So we can simply write cosine of A. Do you follow? Now, if you are to take sine of negative A, this is actually equal to the negative of sine of A. So they're not equal. So for sine of negative A, again, this is equal to negative sine of A. You can check that in your calculator. If you are to, take sine of minus 90, it will give you, of course, negative, okay, value. So, and if you take the positive, yeah, sine of 90, it's positive. So it means that for them to be able to have an equal, for them to be equal, so you have to put the negative sign before, the sign of the positive number. Okay? Again, cosine of negative is equal to cosine of the positive. Cosine of negative A equal to cosine of A. Now, sine of negative A is equal to negative sine of positive A. Now, for the next one, okay, so as written earlier, so e raised to A plus B times I times the quantity x is equal to the factored form e raised to ax times e raised to b I times x. Okay, if this is negative, guys, if it's negative, so just put here negative sign, just like this one, okay, above. Now, e raised to ax has no imaginary unit in it, so just copy this one, and you know that e raised to um, this power containing an imaginary unit is equivalent to cosine of bx. So yan lang, bx plus the imaginary unit I times sine of bx. Okay? Do you follow? Then the general solution is, okay, so before I present you, the final, let me just derive, this one. So, let me just derive this one. So y, the general solution equal to e raised to ax, of course, we have utilized these illustrations. Okay, so continuing, okay, from this part here, let's just continue. Let me just stop sharing and then share my whiteboard. Okay, so let me rewrite again the solution. So this is y equals, or the y sub c is equal to c sub 3, I think. Yeah, that's e raised to ax, right? Times e raised to, of course, bi x plus c sub 4 e raised to ax times e raised to minus b I x. Okay, now we can factor out e raised to ax. So this will become e raised to ax. Let me just rewrite. E raised to ax. What else? So here we can say here c sub 3 times. So this one, okay, remember, yeah, this one has an imaginary unit, the same with this part. So we can actually rewrite, okay, it's equivalent to Euler equation. This is cosine of, what's this? Cosine of bx. Since it's positive, so you just add, yeah, an I sine of bx. Okay, now we have, okay, the next term. So C sub 4, okay, multiplied to, of course, this is negative, right? So cosine of negative bx is similar to cosine of bx. Okay, so just copy cosine of bx. And then sine of negative is equal to negative of the sine of the positive. So you put minus I sine of bx here. Okay, so this is the equivalent, of this corresponding exponential functions with imaginary unit. Now we have to simplify this one. So just copy first e raised to, sorry about that. Okay, e raised to ax. Okay, now let us factor out cosine bx. Okay, so let us combine, okay, those with the coefficients of cosine of bx, and that will be, so here we have c sub 3, right? So c sub 3, so you have also c sub 4 in the second term, so plus c sub 4. Okay, did you see it? So these are the coefficients of cosine of bx. Now for the next one, so you just add the end. Now let's focus on sine bx. So it has I in it. So you can put I there before. And then what are the coefficients? You have here c sub 3. And for this one, you have minus. Okay, so minus c sub 4. Okay. Times sine of bx. Okay. So we can simplify this further by, putting this arbitrary constants, the sum of this is equivalent to c sub 1. And this including the imaginary unit, of course, this will be represented by c sub 2. Okay, so even though you cannot see the imaginary unit, so in arbitrary constants, you can simplify. So in this arbitrary constant, it could mean that it could have real numbers and imaginary, or real numbers or imaginary numbers. Okay, so going back to um, a PowerPoint presentation. So there you go. So therefore the solution, the general solution is e raised to ax. A is the real part of our complex number times the quantity c sub 1 cosine of bx. B is the imaginary part, or the coefficient of the imaginary unit, okay, plus c sub 2 sine of bx. Okay, now let's solve example number 1. So find the general solution of y double prime minus y prime plus 2y equal to 0. Okay, so I'll leave example number 2 for you to solve, but if we still have time, I'll be presenting, how to factor this one. Okay, so take a look at this solution. So first thing is to put the equation into its differential operator, notation or form. So y double prime becomes d squared, so minus d plus 2 times y equal to 0. Now, the next step is for you to write the auxiliary equation wherein you replace d by m, of course, auxiliary, so you need not to write y there. So m squared minus m plus 2 equal to 0. Now, if you try to factor this by inspection, you cannot be able to get the roots. So we use the quadratic formula. It's negative b plus or minus square root of b squared minus 4ac over 2a. So b is the coefficient of m here, and of course a is the coefficient of m squared, and c is the constant. So negative of b, which is negative 1, is positive 1 here, plus or minus, so negative b squared, it's positive 1 minus the product of for AC, which is 4 times 1 times 2 is 8. So 1 minus 8 is negative 7 or minus 7. It's inside the squared symbol. So it's square root of negative 7 over 2. Recall that square root of negative 1 is equal to an imaginary unit, or I. Then we can factor this. So square root of 7 times square root of negative 1 is equal to square root of negative 7. So this can be represented, or is equal to square root of 7 over 2 times the imaginary unit, or I. As you can see, this is a distinct imaginary root having its conjugate, so plus or minus. It represents two roots. Okay, so it means that the solution is having two arbitrary constants. Now take a look at these roots. Yung 1/2 is the real part, yun yung A natin. And square root of 7 over 2 is the coefficient of, or is found in the imaginary part of this complex number. Okay, this is B. Now, recall the solution um, for a DE which has distinct imaginary roots and its auxiliary equation. So this is how we write the solution. So A is 1/2. So this is x over 2. C sub 1 cosine of square root of 7 over 2 times x plus c sub 2 sine of square root of 7 over 2 times x. Take note that x is not included in the squared symbol. Okay, it's outside. So this is the argument. Okay, any questions? None? Okay, so no questions. Now let's proceed to example number 2. Okay, so you can have your time to solve this one. So I'll give you a time to solve. So while you're doing it, I'll also be performing it. Okay, please copy first. D cubed minus 4d squared plus 7d times y equal to 0. So while waiting for your answers, I'll be, solving it here also. Try to factor out. Okay, so again, the problem is, for example, number 2, it's d cubed minus 4t squared plus 7d, okay, of y, or times y equal to 0. Okay, so the first step is you write the auxiliary equation. Okay, so while I'm doing this, you should also do it in your, you take your scratch paper and pen. So m cubed minus 4m squared plus 7m equal to 0. Now you think of an appropriate method to factor this. As you can see, m is common in each term, so you can factor out m. This will give us m times m squared minus 4m plus 7 equal to 0. As you can see, m equal to 0 is one of the factors. So you can put m sub 1 equal to 0. And we have a quadratic equation here. So m squared minus 4m plus 7 equal to 0. Now using the quadratic formula, since you cannot, the factors of 7 is 7 and 1 because it's, a prime number. Then we use the quadratic formula to solve for the roots of this quadratic equation. So okay, let me just change the color of this one. Okay, m is equal to negative b, right? So negative b is minus 4. So you put negative 4. Okay, plus or minus square root of b squared. So that is negative 4 squared minus 4ac. So 4 times a is 1, c is 7, Okay, all over 2a, 2 times 1. Okay, so where are you now? Were you able to get the roots? Okay, so m is equal to, so negative times negative 4 is positive 4 divided by 2, it's 2. Okay, plus or minus, so negative 4 squared is positive 16 minus the product of 4, 1, and 7 is 28. So 16 minus 28, this is square root of negative 12 over 2. Okay, so you know that square root of negative 12 is equal to, you can factor out square root of I there, right? So you have square root of I, or square root of 1, square root of minus 1, I mean. Square root of minus 1 is equivalent to the imaginary unit. Now, this 1 square root of 12 is 4 times 3. So square root of 4 is 2. So 2 square root of, 3. Now, plugging it in here, so you have the roots 2 plus or minus 2 square root of 3, okay, over 2. You can cancel 2 times I. Okay, it has imaginary roots. So it means that, what is your A? Your A is equal to 2 and your B is equal to square root of 3. Therefore, the solution for this one is y is equal to, our first root is 0. So that is c sub 1 times e raised to 0, right? E raised to 0 is equal to 1. Okay, so me not write this part. Okay, going back, so just c sub 1 plus, okay, you continue. So e raised to ax, the value of a is 2, so e raised to 2x times c sub 1 cosine of, what is b? Square root of 3. So square root of 3x plus c sub 2 sine of square root of 3x. I'm sorry, so c sub 1, so the subscript should continue. So this will be c sub 2, and this is c sub 3. Okay, I stand corrected. So this is the solution. Okay, any questions? Okay, so this is the final answer. Just compare your solution to mine. C sub 1 plus e raised to 2x times the quantity c sub 2. So the subscripts continues c sub 1, c sub 2, c sub 3. Okay, so there are 3 arbitrary constants since this is a third order DE. Okay, now let's continue with case number 4. Okay, case number 4 is having, of course, if you have roots that are, repeating imaginary, okay, roots of auxiliary equation. So it's analogous to those repeated real roots. So it will contain x in your solution. Okay, for example, if the roots m is equal to, take note that m equal to 1 plus or minus 2i, so this actually contains 2 roots already. So 1 plus 2i and its conjugate 1 minus 2i. So it means that it has 2 arbitrary constants, right? So if this root, or if the roots, okay, are repeated twice, so it means that, okay, it came from a fourth order DE, because here this contains 2 arbitrary constants and another 2 arbitrary constants, so it will have 4 arbitrary constants in your final answer. And taking note that here a is equal to 1, b is equal to 2. Again, b is the coefficient of the imaginary unit. You need not to write the sign in there. This is how you write your solution. Okay, e raised to x, of course, x because a is 1. and then c sub 1 cosine of 2x, 2 is the value of b, plus c sub 2 sine of 2x, plus e raised to x, because it's repeated. The terms here contains x, okay? If it's repeated thrice, then you have x squared as the highest, or 2 is the highest power for x in your solution. But here it's repeated twice, so x cosine of 2x plus c sub 4x sine of 2x. Or you can simplify this one by combining the coefficients of cosine and coefficients of sine. So this is also another form of writing your solution. So here you have e raised to x times combining the coefficients of cosine 2x, c sub 1 plus c sub 3x plus e raised to x, combining the coefficients of sine 2x, c sub 2 plus c sub 4x. Okay, so as you can see, the subscripts are, in alternate form. So if it's odd, so add din to, even subscripts, even subscript. Questions? Okay, now let's go to another example. Solve the DE. Okay, d raised to 6 plus 6d raised to 4 plus 12d squared plus 8, okay, times y equal to 0. Okay, this is 6th order DE, so it contains 6 arbitrary constants, 6 roots. If it's imaginary roots, so it will have only 3 repeating in case if it's repeated, but our topic is repeated imaginary roots, so of course, are expecting to have, repeated imaginary roots here. Okay, first thing is to write the auxiliary equation. So in this case, m raised to 6 plus 6m raised to 4 plus 12m squared plus 8 equal to 0. Now, yeah, you are to observe the given auxiliary equation in what's appropriate method for factoring for you to be able to determine its roots. Okay, so what I did here, since I noticed that there are common factors there, so maybe I can do grouping. So m raised to 6, okay, I'll be grouping this to this constant 8, and then this one, since common yung 6m squared here, and maybe I can factor out 6m squared. Okay, so this is the resulting grouping that I did. M raised to 6 plus 8, and this one 6m to the fourth plus 12m squared. So what I will be doing here is m raised to 6 can be simplified into, of course, m squared raised to 3, and 8, if you take the cube root of this one, it's 2. So I have m squared raised to 3 plus 2 cubed. And here I'll be factoring out 6m squared. So I will have m squared plus 2. Okay, did you see the idea here? Now, going back to the first term, the sum of the cubes, so you can actually factor out this, is equal to m squared plus 2 times what? The square of the first term, and then minus the product, which is 2 times m squared, and then square of the last term, which is 4. So here, m to the fourth minus 2m squared plus 4 times m squared plus 2. Okay, now for the second term, so factoring out, of course, you can see, there is a common factor in each term. So m squared plus 2. You can factor out m squared plus 2, giving us m to the fourth. So you have minus 2m squared plus 6m squared, because we did factor out m squared plus 2. So what will remain is this part here. It will give us positive 4m squared, and then the constant plus 4. And you know that if you factor this, it will give us m squared plus 2, okay, raised to 2. So what have you noticed? M squared plus 2 is repeated thrice, okay? If you are to recheck, so yeah, the cube of this binomial will give us this equation. Okay, so now we are to isolate this one, m squared plus 2. We get the root for that. And that is what? Taking the square root of both sides. So we have plus or minus square root of minus 2. And square root of minus 1 is equal to I. So you have now plus or minus square root of 2 times I. And this is repeated thrice. Again, repeated thrice because of this power 3 here. So taking note that A is not present in there, of course, in this root. So A is 0, B is square root of 2. That's why your final answer in simplified form is C sub 1 plus C sub 3x plus C sub 5 x squared. As you can see, since it's repeated, so you have x in your final answer here. So these are the coefficients of cosine of square root of 2 times x. And these are the coefficients of sine of square root of 2 times x. As you can see, the subscripts are, of course, alternate, or it has a gap. So even subscripts and odd subscripts. Okay, any questions? Questions? Okay, none?
Sir,
Yes.
sir, m equals to plus or minus square root of minus 2 equals to plus or minus square root of 2. How did you get that?
Where? Here? Are you referring to this one? Plus or
Yeah,
minus square root of, because as you know, square root of 2 times square root of negative 1 is, okay, you know that square root of negative 1 is what? I, right?
yeah.
Imaginary unit. So that's why you have I here. Okay?
Okay.
Is it okay?
No.
No?
So the plus or minus square root of negative 2, is it from the formula you got it from, or how did you get
Yeah, here.
minus 2?
M squared plus 2 is equal to 0. So you transpose 2 to the right hand side. So m squared is equal to minus 2, right? So to solve for m, so take the square root of both sides. So you have, of course, two roots here. So plus or minus square root of minus 2. Okay? It has two
Okay.
values. And you know that square root of minus 2 is equal to square root of 2 times square root of negative 1. And square root of negative 1 is equal to I. That's why you have this. Okay? Is it clear now? Okay, so if you have no questions, then we can end this class. Thank you all for attending, and I hope you learned something. So I'll be posting, two separate problem sets for case 1 and 2 and case 3 and 4. So case 1 and 2 will be problem set number 11. Problem set 12 will be cases 3 and 4.
Okay, sir.
Okay.